All right, let's talk about data, but not server data. We're talking about unlocking some serious, massive storage power that's already living right inside your web browser. This is going to be fun. Let's get right into it.
I mean, seriously, think about it for a second. Saving a simple user preference is easy. But what happens when your app gets bigger? When you need to save complex data, maybe user drafts? Or what if you want the whole thing to work completely offline? Where does all that stuff actually live?
Well, to get a handle on this, let's use an analogy. For years, the go-to tool has been local storage. You can think of it like a digital sticky note. It's awesome for jotting down one tiny thing. But what we're talking about today is IndexedDB. And that's not a sticky note. Oh no, it's a full-blown industrial-sized warehouse.
So you might be asking, what's so wrong with the good old sticky note? For simple things, it's fine. But for modern, complex web apps, you hit a wall pretty fast. It has some really serious limitations.
First off, local storage only understands text, just strings. So if you have any complex data, you're stuck constantly converting it back and forth. It's a pain. Second, it's tiny. You get about 5 megabytes and that's it. And maybe worst of all, it's synchronous. That means every time your app reads or writes, it literally freezes everything else for a moment. Not a big deal for a tiny piece of data, but for anything bigger, it just kills the user experience.
So, to get past that sticky note problem, we need something way bigger, way faster, and way more flexible. So it's time to meet the final boss of browser storage, IndexedDB.
And here's the absolute key thing to understand. IndexedDB isn't just another key value store. It is a proper NoSQL transactional database. That just means it's super flexible with how it stores data. And it runs entirely on the user's computer right in their browser. It was built from the ground up to handle huge amounts of structured data, and it's what lets web apps start to feel like powerful native desktop software.
Okay, so how does this giant warehouse actually work? Let's take a quick peek under the hood. Now, I know it might sound a little intimidating, but the basic flow is actually really logical.
Pretty much anything you do follows 4 basic steps. 1, you open a connection to your database. 2, you start what's called a transaction. That's just to make sure your data stays safe and consistent. 3, you pick an object store, which is kind of like a folder where you keep similar items. And finally, 4, you make your request. Add something, update it, or go get it. And the magic word here is asynchronous. It does all this in the background, never ever freezing your app.
Now, all this might sound a bit technical and abstract, right? But I can almost guarantee you've used apps that rely on these exact superpowers every single day, probably without even thinking about it.
Yep, take a look at these, some of the biggest players on the web. So how do they use it? Well, Figma and Canva use IndexedDB to save your complex design files right to your computer, so if your internet connection blinks, you don't lose hours of work. Spotify and Netflix, they can store chunks of audio and video for smooth offline playback. And of course, Google Docs lets you edit huge documents when you're completely offline, and then it syncs up perfectly when you're back online. All of that is powered by this warehouse in your browser.
Okay, so let's put these two, the sticky note and the warehouse, head to head. We'll really see the difference. And then we're going to talk about the one big challenge that sometimes scares developers away from IndexedDB, and, more importantly, the super easy fix.
And wow, this table really lays it all out. It's not even a fair fight. Local storage, just strengths. IndexedDB, it can handle complex objects, entire files, you name it. The limit? 5 megabytes for local storage versus potentially gigabytes for IndexedDB. And performance? One is slow and freezes your app. The other is fast and asynchronous, keeping your UI feeling buttery smooth. It's night and day.
So just to recap the big wins here, you get enormous capacity. You get to store pretty much any kind of data you want without fiddling with it. You get that non-blocking performance, and this one is huge, you get indexes. That means you can ask complex questions like, hey, find me all the notes I tagged with work, and get an answer back instantly right in the browser.
But, it's not all sunshine and roses. The native way to use it is kinda clunky. It's based on listening for events, like success or error, which can make your code a bit messy. Managing different versions of your database can also be complex. And let's be honest, if all you need to save is whether a user wants dark mode or light mode, this is like using a cannon to kill a mosquito. It's total overkill.
But here it is. Here's the pro tip that basically solves the biggest problem. There's a tiny, amazing library called IDB. What it does is it wraps that old, clunky event system in modern code called promises. This lets you use beautiful, clean, easy-to-read async await syntax. You get all the incredible power of IndexedDB, but with a developer experience that just feels so much better. It really is the best of both worlds.
So, when you put this all together, what's the big picture here? What does having this kind of raw power sitting inside the browser actually mean for the future of the web?
You know, the key takeaway is actually pretty simple. If you are building a serious, complex web application, especially one that has to work offline or juggle huge amounts of data on the client side, IndexedDB isn't just some nice-to-have option. It is absolutely essential. It is your new best friend.
And that really just leaves us with one last, really interesting question to chew on. When our web apps can save gigabytes of data locally, work perfectly offline, and run complex searches in an instant without ever talking to a server, does that finally just completely blur the line between what we call a website and a full-on desktop application? It's something to think about. Thanks for tuning in.